Hello students, in today's lecture I will discuss about two-dimensional transformation. Transformation means altering or manipulating display. We have already seen how to draw object on CRT screen. Now what we have to do, we have to change the orientation, that means the position, size and shape of an object, and this could be done through geometric transformations. And basically there are 5 geometric transformations. First is translation, second is rotation, third is scaling, fourth is reflection, and the last is shear. Translation means changing the position of an object along the straight line. Rotation means rotating any object along the circular path. Scaling means changing the size of an object. Reflection means producing mirror image of an object. Shear means changing the shape of an object. So these are the 5 geometric transformations, and translation, rotation and scaling, these are the basic geometric transformations. So you can see in the figure, here we are having an object and we are rotating the object. So again it is a kind of transformation. So first is translation. Translation can be defined as a translation is applied to an object by repositioning it along a straight line path from one coordinate location to another. So you can see in the figure, we are having an object and we are changing the position of an object along the straight line, and the final position is this. So you can say that we have performed translation on this object. Now to translate a point from coordinate position x, y to another x dash, y dash, we add algebraically the translation distances tx and ty to original coordinate. So what is happening, whenever you are changing the position of an object, you have to add translation distance tx and ty in the coordinate positions of an object. So in x coordinate we are adding tx and in y coordinate we are adding ty. The translation distance pair tx, ty is called as translation vector, or they are also called as shift vector. Now translation is a movement of an object without deformation. So you can see, whenever you are doing translation, you are just changing the position of an object. The size and shape of the object remains the same. So there is no deformation in the shape or size of an object. Every position or point is translated by the same amount. When a straight line is translated, then it will be drawn using endpoints. So if you are doing translation of a line, so what you are doing, you are adding the translation vector in initial point as well as in the final point. For translating polygon, each vertex of the polygon is converted to a new position. For example, we are having a circle and we have to reposition that circle. So what we are doing, we will add the translation vector at the center of the circle. If the center of the circle is xc, yc, then we are adding the translation distances in xc and yc. By that, what is happening, the circle will move to the new position. So you can see in the figure, here we are having a point p, x, y, and we are moving this point along the straight line. For that, we have to need the translation vector, and the new position could be x dash, y dash. Similarly, we are having a triangle. So triangle is having 3 sides. objects and 3 vertices. So what is happening? We are adding translation distances at each vertex position. So this is the new position of the triangle. So here is an example of a circle. Given a circle C with radius 10 and center 1,4, apply the translation with distance 5 towards x-axis and 1 towards y-axis. Obtain the new coordinates of C without changing its radius. So we know that the center of the circle is 1,4. Translation vector is already given to us. Along x-axis we have to apply 5 units. Along the y-axis we have to apply 1 unit. So we can say that the value of tx is 5 and the value of ty is 1. Now what we are doing, we are adding 5 in x value and we are adding 1 in the y value. So these are the new coordinates. So you can see the new center of the circle is 6, 5. Previously it was 1,4 and now it becomes 6, 5. This is the second example. Here we are having a square having vertices A03, B33, C30 and D00. Now we need to apply the translation vector 1 along the x-axis and 1 along the y-axis. So what we have to do, we have to add these translation distances in x value and as well as in the y value. After that you can see the position of the square has been changed and this is the new position. So you can see the new coordinates are 1,4, 4,4, 4,1 and 1,1. Now the second transformation is scaling. Scaling means changing the size of an object. It is used to alter or change the size of an object. The change is done using scaling factors. In translation we are adding the translation vectors, while in scaling what we are doing, we are multiplying the scaling factors. Here we are having two scaling factors. First is sx and second is sy. If the original position is x and y, scaling factors are sx and sy, then the value of coordinate after scaling will be x dash and y dash. Scalar multiples all coordinates. So what we are doing in scaling, we are multiplying the translation, the scaling factors. So you can see that the value of x dash is equals to sx into x and the value of y dash is equals to sy into y. If the picture is to be enlarged to twice its original size, then we have to set the value of sx and sy as 2. So if you are changing the size to double, then obviously you have to set the value of sx and sy as 2. Now if sx and sy are not equal, then scaling will occur, but it will elongate or distort the picture. If scaling factors are less than 1, then the size of an object will be reduced. If you are keeping the value of sx and sy as less than 1, then definitely this will reduce the size of an object. If you are taking more than 1, then obviously it will increase the size of an object. And if you are keeping the value of sx and sy as 1, in that case the size of an object will remain same. When the value of sx and sy are same, then we could call it as uniform scaling, while in the other case, if the values are not same, then we call it as differential scaling. If scaling factors with value less than 1 will move the object closer to coordinate of origin. So whenever you are keeping the value less than 1, you are shifting the object towards the origin, while if you are taking the value more than 1, then that means you are moving the object away from the origin. So here is an example of scaling. So we are having a square. These are the coordinates and the scaling factors are 2 towards x-axis and 3 towards y-axis. So what we have to do, we have to multiply 2 in x value and we have to multiply 3 in the y value. So you can see the new coordinates will become 0, 9, 6, 9, 6, 0 and 0, 0. So you can see that the size of an object has been enlarged. So this is all about two-dimensional transformations. In this lecture we discussed about translation and scaling. In the next lecture we will discuss about rotation and reflection. Thank you.